Dobro jutro, ili ti GM, or GM. Yesterday's talk that Bogdan gave me the thought that, yeah, we are early in this, and Vyper is also early, but you will see that. So what is the big thing that we always say in the blockchain space is do your own research. You should check the community, the founders, everything around them, see if they are okay. But yeah, scammers are doing a good job to do everything about it so that you believe that they are real. And the only thing that is valid in this space is that code is law. Whatever is in the code will be executed. We cannot say people to the masses to go and check the code. Why? Because we are engineers. We have been trained to do things and think differently. We have design patterns that we learn. And when we see something, we can say, this is this design pattern, and I know how everything is done in the files, and I can read that. What would you say if you go to a lawyer, he goes through your contract, because you don't understand it, of course, and say, this is my opinion, but you should do your own research and do things based upon that. You would say that this wasn't worth your money, this doesn't know anything, and what is this? Legal documents, contracts are written so that many people can read them, turn to a lawyer when they have ambiguity in it, and to see how that is fit in the big part of the law. So for this, group have come together. Vitalik has started it and started a new programming language that is working on EVM, and that would be Vyper. What are the goals of Vyper? Is to enhance security, and not just security as in the blockchain, that it's immutable, that only one key can open a token and things like that, but security for us engineers, because we are a clever bunch and we can write really good code and really make it complex in the code, and things get hidden in it. So Vyper is made for simplicity. There are no complex things in it, and you will see that later. And this is all made because of readability, because I'm a Python developer. I come from there, and we have a mantra, and part of it is readability counts. So Vyper contracts are made for audibility, for anyone to come in, to read it, and to grow through it. What it is not, and its goal is not, is to be a replacement for Solidity. As we say, the right tool for the right job. There are things that Vyper cannot really do, and Solidity might be a better option. And for some things, now it is a better option. And Solidity has been made, at least what I think is, for the simple reason that you will have a developer who can do everything. He can do front-end in JavaScript, he can do back-end in Node.js, because it's JavaScript, and so it is like JavaScript, so that it's familiar to get in as much developers as they can. But with that, they invited developers who had experience with systems where they don't really have to think about memory allocation, what the user will do, if it goes into infinite loops, things like that. And they put them in an environment where it's EVM, it's a virtual machine running, where every little thing counts. Before we move forward, let's just go briefly through what smart contracts are for those people who are not really into everything here. So they just execute functions on the blockchain and change its state. They have to have a caller, must have a caller, so they cannot do things just by themselves on some conditions. Why we like them is that the infinite possibilities that interaction between smart contracts give us. And of course, they're immutable. Whatever you write and put it on the blockchain will stay there forever. So if you write code that has an issue, it stays there. You can, there are techniques where you can redirect the user to another smart contract, but the old smart contract is still there. What features does Vyper give us? It is EVM. It's running EVM, so it is compiling code into EVM code. It is Pythonic. As a Python developer, for me, Python is the language most close to the English language and the most easier to read. It has strong typing. I'm a Python developer, as I said many times. I like that typing, and I was like, why strong typing? But at the end of the presentation, you will see why they went for that route. But let's move forward. So strong typing is there. It has to be decidable. So whenever you want to call a smart contract, a function on a smart contract, you need to be able not to simulate it. You need to be able to tell how much it will cost, how much gas you need to send into the system for the function to be executed. And for this reason, it has to be decidable. We have bounds and overflow checks on arrays. And the compiler code is small and understandable. You can even go into the compiler code and see it for yourself how it is working, how it is compiling the code into bytecode. Let's take a closer look at a simple smart contract written in Vyper. What was strange for me at first, because I'm a beginner, so I didn't write Vyper smart contracts for years and years, and that's why I think I'm a good fit to try to explain to you what it is doing and what it cannot do. So what was strange for me is that there is no class definitions. When you write a smart contract in Solidity, what you do is create a file, and you say that it's a contract called this and this. And then you have the whole code intended from there, and you have an indentation at each line. For me, that was like redundant, because the file is already telling you what the name of the contract is. So they removed that. There is no definition like a class definition, but you still have a self. If someone is a Python developer, do we have Python developers here? Yeah, back there. Whoa! So they know that that self is usually the keyword that you are using to refer to an object, to itself. And they kept that here. So, but the self is referring to anything that is in this file defined. So the functions, the variables, as you can see, we define some variables outside of these functions, and those are referred with self. There are also ways to add interfaces. Vyper has some standard ERC interfaces in it predefined, so we can just define and import it, and tell that this will be implementing interface. And in that case, whenever we want to compile it, it will tell us this function you are missing. This function is not defined, doesn't have the correct parameters, and things like that. So you can be sure that you are implementing a smart contract that is according to the standard. As you can see in the function calls, there are some variables defined, and what is different from the variables outside of the functions is that you have to initialize them in the memory, while the storage, the variables outside of the functions are storage variables that they cannot be initialized. And you still have the global variable message from Solidity, where you can refer back to the message that was sent into the smart contract when calling a function. A bit comparison, Solidity with Vyper, yeah. Vyper has fewer resources, tutorials, so wherever you search for it on Google, you will get less returned links than for Solidity, of course. You have limited tooling and integrations. The Vyper has some of its own frameworks and toolings that you can use, but they have also some integrations to Foundry, Hardhat, which is in progress. There are not many contracts written in Vyper. It's like a self-fulfilling prophecy. I will write it in Solidity because everyone is writing it in Solidity, and then everyone knows it, and that means fewer developers also. And it's a bit uncertain because of these reasons about its future and where it will go and about its adoption. There are also some limitations. So these are the big things that you can see when you are writing smart contract different from Solidity. So in Solidity, in Vyper, there is no inheritance. As you saw, there are no classes, no contracts defined. But you will maybe have modules. So that's a new thing that they are working on, because this is good from the readability perspective, because everything is in here. As you can see, this is a basic ERC721 smart contract. In Solidity, it took me 16 lines. It could be maybe less. But in Vyper, it's 371 lines. Because what do you do without inheritance? You are going to a smart contract or a default implementation and copying that into your file. So you are just copy-pasting it over. This has the issue, what happens if the smart contract that you copied over had a bug, had an issue? That you have to follow all of these that you want to use, and then make the fixes copy over into your code. And especially if you change the code that you copied, you have to incorporate that. Inheritance has issues with readability, because you can extend a class that extends a class that extends a class, and you have a hierarchy. And you can have external functions that are hidden somewhere down in the 5th level, 6th level. So it's for the reader, it gets confusing. You don't have modifiers from Solidity in Vyper. Why? Because those are effectively functions. They are called modifiers. That's the keyword. But they are effectively functions that you can call. And what will happen? In this case, when you call change price, it will go to the only owner before calling the body of the change price function. It will check whatever is there, that the message sender has to be the owner of the contract. And then it will execute the change price body that is defined in the function. This has issues, as that function, because of inheritance, can be defined anywhere. And it usually is. There is a contract on OpenZeppelin for ownable. So it can be down there. But you can change it a bit and make the function execute something that the caller doesn't want to do. For this reason, Vyper told this, because it's usually used for some kind of checks before you run the body of the function, that it should be done inline. As you can see on the right side, on the line 12, it's just this. You are asserting that the message sender is the owner of the contract that has put up there. So for this reason, there are no modifiers. This is done in Vyper to not get into a situation like this, where you are going down the rabbit hole, following through all the inheritances and modifiers and things like that. You should be able to read line by line the code that is executed. There's no function overloading. This is just one piece of code written in Solidity. I don't have within Vyper, because Vyper doesn't have overloading. And what I wanted to show here is that, we have a mint function defined 2 times. One is receiving an integer, and the other one is receiving a string. So depending on whatever the caller wants to do, they might just think, I will call whatever function, because it's mint, it is receiving a token ID. And if they are not careful, they can probably you lose their Board API Club monkeys, according to this smart contract here. While the other function will really mean something. I left out all the code for minting, it's just the transfer, but this shouldn't happen, that someone needs to think about it, which function to call. According to that Python little Zen poem, in face of ambiguity, refuse the temptation to guess. So there should be one function that is defined, and if another function is doing something a bit differently, give it another name. There is no inline assembly. Why? Because it makes reading the code more complex. You need to know a second language. You need to know assembly, how it is working. What are these commands here? It's not enough just to know how to read Solidity, but another language. And it is going down into the details of how something is executed on the byte level. So that's not good for readability in any case. And for that reason, there is no inline assembly. And don't give it into a temptation. I know the temptation is high to optimize everything out and to spare a few guesses for whoever is calling the contract, but contract readability is more important for whoever is calling than to spare a few guesses. There is no recursion. Why? Because the recursion can go infinitely if someone wrote it like that. And one of the things that Vyper wants to give us is decidability. We need to know in advance how much gas we need to pay. In case of the left side of the Solidity code, this will go infinitely. If this was in any other programming language that is running on our computer, it would just hang there. And yeah, when we get bored, we can just stop it. In case of Ethereum, it will just stop after it spent all the gas. For this reason, it is forbidden. As you can see on the right side, Vyper even gives you, when you try to compile the code, it will go into it, try to see it, and it will give you an error. You cannot deploy that. You cannot compile this code because it has recursion in it. Also, there are no infinite loops. Why? For the same reason. Because, yeah, we need to know how much gas we can spend. There is no while keyword even in Vyper. You only have 4 loops that can go over an array. And if you want to go a certain number of times, you will call the range keyword, which will generate for you an array. And it is always working like that. So you will always know how many times the loop will go through. There is no infinite loops. And yeah, I know no one is doing this, but yeah, then why should it be there in Solidity or in any language that you are using? So we are trying to tell people, yeah, this is a trustless system, and yet they have to trust us, that we will do a good job, that we won't write code like that, but with that, there are malicious entities who can write code like that. In Vyper, we are preventing that. And getting back to why it's strongly typed, it's because of the memory handling, how memory is handled. So what we also have is that we have statically sized data. We cannot have arrays or string that we don't know the length at compile time. We have to define how long of things we want to have. And we must, for example, in functions, define them by values. Why we are doing this? Because allocation happens at compile time and not at runtime. For this reason, the compiler needs to know how big of a memory it needs to assign. And this is even more gas efficient. And let me explain why. This is how memory works in Vyper. You define a function, and in it you define some variables in the memory. You see that there is an integer and the Boolean variable. First, the integer is defined. It will assign it to the first slot in the memory. I know that the memory doesn't really work like this, but this is just an abstraction to get the point over. And the next slot will be assigned to the Boolean. This will be done at compile time. So in the byte code, the address directly in hex code will be written there. It doesn't have to think about it. It will always put it at the same place. While in Solidity, what are they doing? We have a free memory pointer because we wanted uncountable arrays. We wanted to have arrays that we just putting something in, and we don't know how many times we will do that. So for this reason, this is, for example, the memory, but you have a free memory pointer. And the free memory pointer is just a location in the memory where it is written in the next location in the memory that is available to write something in. So when we want to add something into the memory, we want to go to the free memory pointer, look what is written in there. We had to go to that address that is written in the free memory pointer, write the data in there, in that location, and then we have to get back to the free memory pointer and update it to point to the next available memory location that we can write into. For this reason, as you can see, just assigning the memory is more expensive to be done, and with this, you can get a bit of gas efficiency in your Vyper code. What can I say for the end? This wasn't financial or legal advice. Do your own research. We are heading west. This is the frontier. So I'm just here to ramble a bit about Vyper. And to make this easier for you, I will give some directions for you. You can go to the documentations that are really good. They are not that long. You can just go over, see it's really good, structured nicely, and try to learn from it. You can try live code. So you just go to this address, tryvyperlang.org, and there's a Jupyter there that you can start. You can write your code and test it live in your web browser. You don't have to install anything. There is a learn page also for Vyperlang, where you can go here in. You get some assignments, and you can write them in your browser. It is not really compiling them and stuff like that, but it will check your code that you've written, and you can learn from there. You can learn the most when you are learning from those that have already gone before you. Curve has their contracts written in Vyper. So that's a big DApp that you can go over their code and see how they are doing things. One of the tools that Vyper is using is Apex. It's a framework like Hardhat. It is made especially for this, and you can use that. You even have a starter kit that you can just git clone and start working immediately. And of course, everyone has now in this space Discord channel where you can go on. They're really friendly and ask your questions, learn from them, and yeah, that would be it. Thank you. Any questions? Yeah, there.
Is there a reason that you think there are so few people using Vyper? There are many benefits to Vyper. Why are people still using Solidity all the time? Are they lazy?
No. I think that, yeah, writing in Vyper is harder because, as you see, there is no inheritance. You cannot just use OpenZeppelin. You will need to copy-paste. That makes it harder. They are working on modules, which will effectively be something like that. You can define in another file how functions and things like that is still in development. But the main reason they are doing it like that in modules, not in inheritance, because you will, even in that case, in your main contract, have to have a function that is calling the module. So you will have all the functions defined in the main contract, and with that, it will still be readable. There is no hidden functions through inheritance. But yeah, so that might be one of the reasons that it's easy to read, maybe harder to write. So, and we are yeah, we are as developers lazy, and we want just to import something, yeah, attach something to it, and that's it. But also, it's small, so yeah, it's the size. So Solidity had a head start. It got big, and now it's there and keeping its position. But yeah, you see, Curve. Even I think that Uniswap wrote their first version in Vyper, and then they went for Solidity. I'm not sure why. Any more questions? Once, twice, thrice? Nothing? Yeah, then that's it. Thank you.